Dr. Venkatesh Kamath and Dr. Vandana for the last 5 years or so. So we met in ACM Compute at Chitkara. And Dr. Vandana and Dr. Venkatesh were both instrumental in organizing 2 conferences in a short period in 2019 or so in Goa University. ACM T4E and ACM Compute. And during the COVID time, Dr. Vandana organized Deep into Python workshop online. Then I again met Dr. Vandana in Jaipur during the ACM meet there. Okay, so Dr. Kamath was asking me this question. Can we teach this way in a classroom? Okay, so would the students be able to understand? We assume that they know C, and we're starting data structures. Can we do this way? The answer is yes. I have tried this from 2011 onwards. I must have taught at least 4 times, if not more, in college in Bangalore, and it has been successful. Students find it a bit difficult in the beginning to play with multiple files, decide where to put what, and after that they get used to it. In the 7th semester, I have offered, 6th or 7th semester, I offered elective like design patterns, and there in a 2-hour period, we have developed programs with some 34 files, right? When students enter the industry, the first thing they find it difficult is to manage multiple files. In a project, there'll be 100 files, right? How do you manage them? So if they get used to this idea that you could have a separate implementation file for each task, it becomes easy. So as I said, in one particular design pattern, I think it was factory pattern, I had 34 files and all developed in front of the students in 2 hours. And many teachers in my college, PES, have changed over seeing my way of doing, right? So I'm sure that you can try out. Email ID I'll anyway share with you. If you remember my name, it's easy to make out. It's Kumaradhara @gmail.com. And in case any of you are familiar with the southern part of the coastal region of Karnataka, there is a river called Kumaradhara, which flows by a place called Subramanya and joins the river Netravati. Okay, I didn't call after the river though. When I came out of my last job in 2000, I had to have a company name, and I called after my name. Kumaradhara means flow, but not to be taken literally. That's how I made the name Kumaradhara. Okay, so I was digressing. Any queries before we answer her that particular doubt, and then confuse you quite a bit by using the board only. Okay, I leave it to you how you copy it down, because I don't know how it can be captured. Or if you feel like taking a snap anytime, please be free to do it. I share my email ID, my phone number, my Facebook ID with my students. They keep coming home. Wherever I go, I'll find some student. Yesterday I went to a restaurant, some student came in and spoke to me. I didn't remember. You see, she graduated in 2018. In December, we went to Gandhinagar. I was invited to give a lecture there, IIT Gandhinagar. And the person who arranged said, we'll get you a guest house for 4 days. You can even bring your wife. So I also took my wife, and after that went around whole of Gujarat for 8 days. Then in Dwarka, somebody said, you look familiar. Did you teach at Siemens? And I was looking at one girl in the airport, and I think she also must have felt something unusual. And she walked to me. I feel your face is familiar. I said same thing. Then she asked, did you teach at HP? Then she said, I was your student. So wherever I go, I keep bumping into my students. It's nice in a way. Yes, okay, one of my friends was asking here about some formalities for research and all that. I know nothing about them. I have been academic. I love computer science. I love teaching, and there the buck stops. And from October, I've almost stopped. doing anything. I might retire now, but I think it's difficult to retire after having been busy for so many years. Right? I love reading. Read a lot. I read English and Kannada. I do not know other languages. I know a bit of Sanskrit, a bit of Hindi. Yeah, okay. Any queries before we proceed? Okay. Many of these things that we're talking about won't be familiar unless you use multiple files. Okay. So what I will do is make a very small file and try to show you. So this is the client program. And this header file is a very simple, a very simple one. I'll have a structure. That's it. Okay. And I include that here. So will it compile c1.c? It compiles, right? What happens if I include the same file twice? Okay. I may do it not purposefully. I may include some other file which also includes this header file, right? In that case, let's see what happens. It now gives a compiled error saying that that particular structure has been defined already. It's a multiple definition. How do we see to it that the header file is included only once, right? For that, we take the help of the preprocessor. So in the preprocessor, hope you're comfortable with the way the program development happens. So the first thing is we edit the program, enter the program into the computer. It's called a source file. Then we pre-process. The output of the preprocessor is called a translation unit, or translation. That is the input to the compiler proper. We compile, then we get what is called an object file. Then combine the object files and the libraries together. By linking, we get what is called a loadable image. And then we load it. In the load, we get a process. And then we run it. And we get some result. Right? This is the way the whole thing goes about. And pre-processing happens before compilation. Right? So what I could do here is this. I could define a variable of the preprocessor. It is not going to be there during compilation. It is not part of the C program. It's a variable of the preprocessor. I can give any name for it. By convention, all the companies use the name of the file itself. They'll have something like this, I1 underscore H or something. Some of them use another couple of underscores on either side. It's a convention. Could be anything. I can call it junk. Perfectly all right. Right? Now look at what happens. When the preprocessor is going through this particular file, at this point, it will open this file and try to go through. When it tries to go through, it will go through this line and define the variable of the preprocessor. Before this point, do we have it? We don't have it, right? I can then check, is it defined or not? Okay, this is the way I check. If it is not defined, go further. Okay, and the requirement of if is that it has to be closed with endif. So now let's go back and look at what happens. When we pre-process the second line. This file is opened. There is no variable of the preprocessor at this point called I1 underscore H. So it will go to the next step, create that, and include the structure. Next time we come here, come to this line, what happens? Again, it comes here, but already this variable has been defined in the earlier step, so it doesn't go through this, it won't include this. This is what we do. Okay? It could be any name, but name is normally made using the name of the file itself. Any queries about this? Okay, one more thing maybe I should tell you before I proceed further. When we have obtained number of files, we had to recompile a few files and then link them together. It's difficult to remember the dependencies, difficult to remember which files had to be recompiled when something changes. Is it possible to transfer that knowledge to a tool? In that tool, I would like to tell file X depends upon Y and Z, and therefore when Y and Z changes, execute these commands to remake X, right? This concept is called build. How many of you have heard of a tool called make? Okay. Unix is an amazing operating system. Do you know who designed it? Any of you know the name of the person who designed Unix? Ken Thompson. He should be in 80s now. What could he be doing now? I want to retire, I'm 62. What could he be doing? He is working for Google and is creating the language called, what's the language? Go. Golang or Go. There's so much of enthusiasm. Have you heard of Kunuth? K-N-U-T-H? If you're teaching DS, you should mention his name, whether anybody reads his books or not. In 70s, he thought of writing a single book on the whole of computer science. Then he felt the book will become too big physically. Each logical chapter became a physical book, Art of Computer Programming. He finished 3 books, Sorting and Searching, Semi-Numeric Algorithms, and another one is what? Algorithms. I think I'm not very sure of the title now. He wrote the 3 books. He wasn't happy with the publishing technology. He developed something called TeX, which later became LaTeX. In case you're writing papers, in many places, you have to use LaTeX only, right? So Kunuth is perfection personified. He's a prof from Stanford. He's 84 years of age. He's still writing the 4th book. Can you imagine? He says, no phone calls, no mails, nothing for the last 4 years. So the amazing people. So Ken Thompson designed an operating system in 70, and he made some tools, and those tools are relevant even today. Right? In our field, things change so fast, isn't it? For a tool to remain unchanged for over 50 years, it's just amazing. The tool is called the make tool. Variations are there, Perforce and nmake, gmake. So, okay. So in case you install MinGW, you'll also get that make tool. So I will show you how to make a make tool, which will capture the dependencies. It'll also capture the command to be executed when something changes. Right? Let me show you that. Is this okay? The point okay? Why we require that if and def? Okay. So I'll create a file, can be any name. So I'll call it mymake.mk, could be anything. And okay. So let's say my final executable should be list, and that in turn depends upon list.o and the client.o. This is the dependency. And then I use a tab here. And here I'll say now GCC list.o client.o. Basically what it says is that look at the last time of modification of the file. If these two have a higher time of modification, recreate using this particular command. Okay, then I'll now say list.o depends upon list.c and list.h, and the command to be executed, there's a tab before this, is this. Similarly, I have client.o depending upon client.h, client.c and list.h. And the command to be executed here is compile the client.c. Okay, this is the way I create the file. Okay, then I'll now say make -f my make.make. Okay, it did all this, right? Now what I will do now is to open, say, one file. Let's say I open list.c. Okay, I just introduce a new line. I've changed the file, right? Now once I go back and try to execute, it will now make out that list.c has changed. Therefore, list.o has to be remade. List.o has changed, list to be remade. This is not going to be executed. It will be able to make out all that. Okay. So this is something, whenever we start a project, we always make it. And And there are cases where this itself will be 1,000 lines in projects in the industry. And executing this may take something like 8 hours. Nothing can be done during that period. In Philips, it seemed they had one which would take 1 hour. So they could go and have lunch and come back. Now they've used a variation of this called parallel make. It's basically a tree structure, process the tree parallelly. So they're using that. Now they can only go for a tea break. It still takes around 20 minutes, right? So these are very important tools. MIT has something called missing semester. Maybe you should check it out. There are many things which we can't teach in a course, but they're required from the industry point of view. GitHub, would you teach that in them anywhere? GitHub, source control. Yeah, those are required, right? We may not be able to get into a course directly. Maybe in a lab, we should be able to get it. The same thing with make also, right? Make itself can be very complicated. We can have something called recursive make calling make again internally. Is that okay? Ready now? We'll use the board. So rearrange if you want so that you can see the board. I don't know how to make it visible at all places. Okay. What we'll try to do is to create a list using an array. We'll fix the size in the beginning. We'll assume at the most we'll have so many elements. We'll go through the same process the way we did now. And then we'll try to delete an element from this. We have not discussed deletion here. We can also discuss the deletion of a list before that. And then see how we can manage it. I taught that in Philips sometime in 2003 or so. Those are the times when you used to get music players, no? Small handheld music players, whatever they were. So within 2-3 days, they came and said, whatever I taught, they used that in that particular product. Okay, so how do we start? If I have a list, the board is a bit small for me. I may have to rub it off sometimes, so please. Let me know when I can clean it up. If I have some elements like this, here's a normal linked list. If I want to delete the node with 25, what do you think I should do? I want to talk about deletion in the other example. I'm trying to build up here. How do I delete this node? Let's say we keep a pointer. I'll call it present, make it point to the first node. The value given is 25. Compare the key there at the node to which present points to, and this, if they match, that's the node to be deleted. Otherwise, go to the next. Then they don't match, go to the next. They match, what do I do? Yeah, I must change the link of the previous node, but I can't move back. It's one-way traffic. So what do you think we should do? Yeah, the way we did earlier, we keep one more pointer tagging behind this. In the beginning, it is null. Then it points here, then it points here. So this is where we stop. And then we can now say, make previous pointer link same as present pointer link. Of course, we should take care of freeing the present node, right? Otherwise, what happens? If you forget to free that node, what will happen? Will you be creating garbage? Will you be creating dangling pointer? What is it? I can't access it. I can't access it. I lost it. I only through present I can access at this function. Once I come out of the function, I can never access it. So is that dangling pointer or garbage? Okay, so would you call that dangling pointer or garbage? It's called a garbage, right? And I'm sure you would have heard of garbage collector, right? Java has a garbage collector based on mark and sweep algorithm. C++ has something called smart pointers. Smart pointers have dumb pointers within them. And these are the terms we use, right? When I use these terms, I feel nothing, right? We talk about executing a program. We execute it. Then we talk about parent-child, orphans, zombies. We're just used to that language, right? And Python has a garbage collector built in based upon a concept called reference counting. We have nothing of that kind in C, right? Okay. So maybe time permitting, we'll discuss a bit of malloc and free and talk about the difference between garbage and dangling pointer. That's very interesting, but let's see. Are you okay with this? So is it okay if I delete this from here? If you want to take a snap or whatever, if you think it's okay, fine, let's leave it there. Now I want to create a list using an array. That will be an assignment for you to try in the afternoon today. Okay, and I'll use the same elements I used while creating the list. I think I used some 20, 10, 40, something like that. Okay, we'll use something similar. And my list is not having a header node. So this is the first snapshot. This is the array implementation of the list. And the head is -1. Okay. So indicating that it is grounded. Because 0 is a valid index here, right? So I use -1 as the index to indicate the list is grounded. Is that okay? Now, I want to add 40 here. 20, let's say. Where shall I add 20? In case of the linked list implementation, I would allocate a node each time, and temp would point to it. So here also I'll use temp, but temp shall be just an integer. It's an index. So in the first attempt that I'm trying out, it's not the complete one, I'll assume the temp is going to change from 0 to 4 contiguously. Are you okay with this? So I'll take temp as 0, and at that place, I'll put 20. But this is not sufficient, right? This is the key. I also should have a field called the link field. It's an array of nodes. But the nodes are all having links as indices, they're integer and not pointers. If you want to create a list in a hard disk, they can't be pointers. They have to be offsets in the file, right? So how do we add the first node? What should happen to the link field of that first node? What did we do? First node, what will be the link field? Null. So here I'll make it -1. Okay? And what should happen to the head? It should become the first node. Are you okay with this? So the first node is in position 0, and there is no node after that. It's grounded. I have now shown an example of insertion in the beginning. Okay? Now let's try the next step. This is what we have at this point. We want to add 10 to the list. As I said, I'm assuming the temp will change contiguously. It's a simplicity that I'm using now, but I'll change it to make it a bit more challenging. Okay, I'll put the 10 here. Are you okay so far? Now you must do the insertion. How do we start doing the insertion? We have to have 2 links to walk through, right? We'll have here also similar to the way we had earlier, previous and present. What should be the initial value of previous? Remember our first implementation. What was previous in the beginning? Null, right? Grounded. So what should happen here in this case? In array implementation, it should become -1, right? And what should happen to present? It should become same as the head. So head here is 0, so this becomes 0. So what do we do now? How do we insert? Take the value in the present node, compare with the key. If key is less than present, what does it mean? Already we have found the position for insertion. Right? How do we insert? This is a case of previous is still -1, it's grounded. It's a case of insertion in the beginning. When you insert in the beginning, the head will change. So what should happen now? The head should become 1, and what else should change? This should take the value of present. Temp arrow link equals present, right? So this should take the value of present, which is 0. Check the list now. The first element in position 1, first element in position 1, next element in position 0, and nothing follows. Is that comfortable so far? Okay. Still very cool days. It will become hot a bit later. Okay. So we'll again take a snapshot of what it was before and then try the change. And I want to insert 40. So I'll again assume that I can get the next position by incrementing temp. So I get 2, I put 40 here. To insert, I use previous and present. Previous is grounded, present is same as the head. Right? How do you proceed now? Previous is always grounded, is -1. Always -1. Because we assume that head is -1 in the beginning, that's a grounding. Right? Present will be same as the head. So the first node is here, right? It's compared with 40. 10 less than 40 is true, so I should go to the next node. So previous becomes present, and present becomes link of present. Link of present is 0. Now I compare 20 with 40. So 20 is still less than 40. I should go to the next node. Previous takes the value of present. Present takes the value of link of present, which is -1. Now present got grounded. That means I should come out of the loop. And that's an insertion at the end. And the code is same anyway for insertion in the middle or the end. So what do? Link of previous should take the value of temp. Can you imagine that? Link of previous should take the value of temp. Previous is 0. Link of previous takes the value of temp. So this becomes 2. Link of temp takes the value of present. Link of temp takes the value of present, which is -1. Check the list. First element in position 1, 10. Next in position 0, 20. Next in position 2, 40, and nothing follows. Are you comfortable? Hope you had enough of coffee and our tea. Next, I think when we try, I think maybe one of you can help me out so it becomes easier. Wish they had put the board the other way. Okay. Anybody wants to help me in this? Any volunteers? How many of you are confused? It's possible. I'm not joking at all. I know you're confused. Then you are the best candidate for me to help now. How do we start? We have to insert not in the beginning. So what do you think we should do? No, it's similar to the earlier case. Whenever you want to insert in a linked list, in the middle, what do? You have to find the position. How do you find the position? No, you have to require 2 pointers there, right? Yeah. So we'll also take 2 such things. They're not pointers, they're indices. Right? Previous and present. Okay, fine. So we'll have previous and present. Okay, please try to stay with me. These are notes, please ask immediately. Is that okay? What should be the value of previous? What should be present? Where should present point to? The first node in the list. And previous should be behind that. Which is the first node in the list? Head has the first node in the list. Head is 2, is it? Head is 1. Head is 1. 10 is the smallest number, right? So head is 1. That is present. Are you okay with this? Present should be same as the head. Head points to the first element in the list, which is the smallest element in the list because we are making an ordered list. And previous should be behind that. Behind nothing is there. That means it is grounding. And grounding in this array implementation is -1. Are you okay with the 2 initializations, previous and present? In the linked list implementation, previous is null, present is same as head. In the array implementation, present is same as the head, previous is -1. What is null there is -1 here. Are you okay? Now what do you think I should do now? I must look at the value in the present node, 10, compare with 25. Okay, temp is not 25, temp is 3, sorry. So what do you find? 10 is less than 25. What do you think you should do when that happens? Go to the next node. How do you go to the next node? What should happen to previous? Should take the present value. It should move up. And present should take present arrow link, a link of present. Correct? So what should happen here now? Previous becomes 1. And this becomes link of 1. That means now we have moved from 10 to 20. Then what do? We compare 20 with 25. Is it true? Yes. We should move to the next node. What do? Previous should become present 0. This should become link of 0, 2. Now, where are we looking at? We're looking at value here, 2. That's not less than 25. It means between the previous and the present nodes, we have found a position. We're inserting in the middle. Between the previous and the present, we have found a position. How do we insert? Link of previous is temp. Link of temp is present. You can imagine that, right? So what do you think I should do here now? Link of previous is 0. Link of previous should take the value of present, which is, what is this? Link of previous should take the value of temp. Temp is 3. So this becomes 3. And link of temp takes the value of present, which is 2. Now check whether it works correctly. How do we start? First element in position, head 1, 10, smallest element. Next in position, 0, 20. Next in position, 3, 25. Next in position 2, which is 40. Nothing follows. Comfortable? So how many of you are still uncomfortable? It's perfectly all right. I must have taught something similar at least 10 times, if not more. And it's not uncommon that we get people who are not very comfortable. So we'll try one more and then experiment further. So the fifth one, I take the value as 30. And head is 1 and temp is 4. Previous is grounded. The present takes the value of head. So who wants to try now? How many of you are comfortable? Can you raise the hand? How many of you are comfortable? Nobody's comfortable? Somewhat comfortable. No, if this is not comfortable, the next thing will not be possible at all. It will go over the head. Please ask, right? It's total freedom for you. You can ask me anything, anywhere, anytime. I'm assuming that all of you are familiar with the linked list implementation. We also did that without, of course, going through the explanation of it. If you're not comfortable, it will not proceed on this. It doesn't make sense. What shall we do? Hmm? Shall we continue with this or drop this? I keep flexibility. That's the reason I don't make PowerPoint slides. If I make slides, I have to run through them and show that they are there. At the end of the day, it's not useful. How many of you have shoulder problem? You can't raise your hand for any of the two. Yeah? I thought you had some.
Just raise it for once for us to understand, because of 2 minutes.
Yeah, that's what. We can do the last one very slowly.
Yeah, like individually we work out.
You want to try it out now? Yeah, try the last one and tell me.
No, not there. Like individually now, at once, just for us to match whether what we understood is whatever.
Okay, do it then we can discuss. Maybe you can try on your own paper and then discuss. No issues. See, this field is very vast, right? We can have 100 hours of discussion and still it be incomplete. One thing computer science will teach you is patience. If there is no patience, you can't do anything in this. Are you all okay, or you still have problems in that? Are you comfortable with this? But you didn't raise the hand for either. What do you teach?
So I have not touched data structure since my engineering. So it's a long gap. I have taught other subjects.
Like what?
PBMS I have done, software engineering, operating system I have done.
Software engineering is one thing I refuse to teach. They said, give me 20 students, I will do, otherwise I won't do.
Why, sir?
It doesn't scale up easily, right? So basically, you should make them do a project understand. We have done it in companies. We done it in companies where we'll have some 10 teams, and what one team does will be spread by another team and so on.
And then continue.
That you can't do in a class of 100 people. What do you teach?
So I teach Java, I teach subjects like JSP. We are teaching for vocational students.
Okay.
That is software technology, skill development according to education.
What do you?
Full stack web development.
Web development.
And then class Python.
Okay. Some courses I didn't teach. One was software engineering. Some course I somehow never got a chance to teach. I don't know. DBMS I wanted to teach, I never taught. And I wanted to teach linear algebra. That also somehow never happened.
Which one, sir?
Linear algebra, matrices.
That is one.
I love. I taught ML, I taught OS, I taught Unispa. I think I must have taught. I think I taught every course in computer science, but for some 3 or 3.
So many years.
You know, I told my CEO, you should give different courses for me each semester. I don't want to repeat courses. One course I never refused was algorithms. I taught a number of times. It is amazing. What I suggest is you try on your own from the beginning. Will take some 10 minutes time. Right from the beginning, you start doing it and compare with what you got. If there's anything, you can call me, I'll come over. I suggest right from the beginning you start. If there's any issue, call me, I'll come over and help you. Yeah, is it okay?
That's fine.
You're talking the last one, is it?
Yeah.
Okay, yeah, at 30. So, ten. This just a minute. Okay.
Practice or something.
Huh?
Just try to figure out. Is it something like this?
It's exactly like the linked list itself.
Yeah, so 10 is connected to 2, 2 is connected to 25.
Yeah, 40 and now 30 will come in between.
No, 30 I didn't try till
Yeah,
here.
it's exactly same thing, no different. And the head will point to this.
So just I want to confirm one thing. Whether we're adding previous or next.
Between previous and present, we are adding.
Between previous and
That's the reason. Previous arrow link will become temp. Temp arrow link will become present.
there only I'm getting confused. Just a bit of. We draw it in diagram way, then it becomes simple.
Actually, we normally struggle with pointers, right? But now we're struggling with integers. Okay, let's say we have something like 25 and 40. Okay, previous is here,
Okay.
present is here,
Oh, correct.
and then 30 temp is here.
Okay. So
Okay.
30 should come here in between.
So previous arrow link is this,
Yes. Correct.
and temp arrow link is this.
Yes.
So previous arrow link is this. The way we write in pointers is like this, and temp arrow link is present. So between the previous and present, we insert.
Correct.
That's what we are doing there also.
Okay.
No difference at all.
Normally we do it in English, but it becomes easy to figure out.
That's what I'm saying.
Here
Normally we struggle with pointers.
We shifted our vision from English to the
Sorry.
we shifted our vision from direct English to the arrays. So, madam.
Come again?
Finally, it should point to minus.
You're inserting last one, right?
Yes.
So, what is the value of previous is 2. No, it will stop before that. It won't become minus 1. Because at some point,
It doesn't go.
the value is 30, right?
30 we insert.
Yeah, so let me start. So, previous is null.
Yeah, minus 1.
Present,
Present is 1.
same as the head,
Yeah, 1.
1. Okay. So, you're now comparing 10 with 30.
10 with
10 less than 30 should go to the next node.
30 the double.
So previous will take the value of present. Present takes the link of present, which is 0. So that's 20 now.
20, right?
20 with 30. 20 less than 30. So go to the next. Previous and present takes the value of link of present. Link of present 0. There's 3.
So 2 is long.
3, right?
Right? You get 3. Now the value at 3 is 25. Is less than 30. Go to the next node. Previous takes this, and this becomes link of 3, which is 2.
2, yeah, right.
Now this is 40, and 40 is greater than 30. So now we have to insert. So to insert, what do we do? In this link field of temp, take the value of temp. Link field of temp, take the value of present. Okay, and link value field of previous, take the value of temp. See, link of previous should be temp, and link of temp takes the value of present. Okay, link of temp should take the value of present, which is 2. Okay, link. Now if you observe, head is here 10, next element here 20, next position 3, 25, next 30 now, and next 40.
So came up till here and then
You moved one extra step.
insertion is
You should stop there and check. You moved one more step unnecessarily. Are you able to figure out? Okay. You want me to help? Yes.
Next 25 is
Two cancel करूँ 4
Huh. No, let's see. What is the head value? Head is, you prefer head is 1. That also you should write, otherwise it will be difficult, right? Head is 1. You come here 10, 0, 20, 3, 25, 4, 30. Oh, you've done it.
But temp should be 4. Temp is 4.
10 will go to 0.
No, temp is 4.
Temp is 4 only.
Yeah. Temp, they're not written head and temp there. Okay. So we had now 2 alternates. Okay. Either we continue with this discussion or leave it there and say you can try this. You decide. If you're comfortable, we can continue and see. Huh? Assuming that you don't have your shoulder problems, can you tell me how many of you want to go deeper into this? Please raise the hand so at least you'll know. Okay. How many of you? See, this is assuming that temp is always available to me, right? It won't happen if I keep deleting. Then we have to see whether we can merge them together. That's the challenge totally. So if you feel you're very uncomfortable, just leave it there. It's not an issue, right? It's huge. Or if you think we can continue in this, you're learning something, we'll go ahead. So how many of you, at least raise a hand for either of them, how many of you want me to continue in this? Okay. How many of you do not want me to continue in this? Please raise the hand for either of them. No, okay. No, no, okay. 3 no's, quite a few years, and lots of nota. Right? So you can never form a government with so many notas. Think about it. At least answer one of them, please. I'm very serious about it. Otherwise, I won't know what to do. To continue or not to continue. How many of you do not want me to continue this? No, you don't want this. Okay, fine. How many of you want me to continue this? Okay, I think we'll forget about the nota. Others want to continue. We'll continue, but do slowly. Those of you who do not also should be able to join me. Okay. It may take another maybe half an hour totally. We'll try to go slowly. As I said, this was used by Philips immediately. Once I taught them, they used it in their players. Okay. So
can we start?
From the beginning itself. Okay. So I'll do one thing. I'll explain the first step. Maybe you want to go along with, check with this. And if you're stuck, let me know. Okay. Fine. The first difference you observe here, there are no pointers. We only have integers here. Okay? It's a requirement whenever you make a data structure on a hard disk. You said you teach database. What about indices? How do you store it? No, if I want to say search on a table or do some fast operation on it, when you fire a query, it will use an index, right? Normally, index is always there on a primary key. How is that index stored? What is that index? It's actually a data structure called the B tree. or a variation of it. And when you store a B tree, we do it only when the tree is huge, that you can't have in memory. So the index itself is stored on a hard disk. When you do that, you can't use pointers there. There are no pointers on a hard disk, right? Motorola made a terrible mistake in Hyderabad. They stored pointers of a list in a shared memory, and the whole program went for a toss. There, they have to use numbers only. Please understand, this is something which is commonly used in softwares, especially if you know about databases. All the indices are stored in some sort of B trees, B plus tree or whatever, and all the indices have to be integers. There are no pointers on a hard disk, right? To that extent, it makes sense to know this, right? Okay, and there are operating systems where C is supported with no malloc. Nokia phones in the good old days had some C on it. It did not support malloc and free, right? It did not, and even in C++ there was no exception handling. In the good old days, now I think most of them do support it, right? So in that sense, it makes sense. So first thing is that please watch out. It's interesting and I think a lot of joy. So here, when talk about grounding, we use null there, right? Here we use -1 because 0 also is a valid index. Null is same as 0. Is a valid index, correct? So in the beginning, head is grounded. Are you okay with this? Beginning, empty list. If you're not able to see, you can come out here. You can pull the chair, whichever. Okay. Head is grounded. To insert, I require a location, right? How to get location in case of dynamic allocation? We called malloc. Each time we got a value for temp. Here, at this point, I'm making an assumption that temp is going to change from 0 to 4 directly, which is not a proper one, but I'll change it later. Simple assumption is that temp is going to change from 0 to 4. Initially, temp will be 0. That's the location where I put the number. The number given to me at this place is 20. I put that here. So I'm inserting in the empty list. Which is the next element after that? No, I don't even have any. I only put that element, only one element in the list, which is the next element, nothing, right? So what should happen to the link field here? Should be grounded, so I'm going to make it -1. So the first node insertion is over. Any queries at this point? Comfortable? Okay. That's what I said. See, we have to have something to indicate nothing follows. So it should be some index which is not valid. I can take -5, -100, whatever. Here taking -1. Okay. So shall I assume the first one is fine? In the second, I have copied this so far. I have to find the next position to insert. So how do I get it? Increment the value of temp. Temp was 0 earlier. I now make it 1. In that position, I put the new value to be inserted. Okay. Whenever I want to insert into a list which is not empty, I must traverse. To traverse, I require 2 pointers or 2 indices, which in the earlier example also I called it previous and present. In the beginning, previous is grounded. Present is same as the head. So in this case, what do we observe? Grounding is -1. Present is same as head, which is 0. Are you okay with this so far? Then what do I do now? I compare the value key in the present node with the key in the temp node. This key is already greater than temp. That means already I got a position to insert. 20 is not less than 10. That means I got a position to insert. While inserting, what do I do? I check the value of previous. If previous is null, what does it mean? We are inserting in the beginning. When you insert in the beginning, the head will change, right? So can you observe here? What will happen to head? Head takes the value of temp, and link of temp takes the value of present. Temp arrow link is present. So link temp is 1. Link of them takes the value of present, which is 0. You can check that now. Head is in position 1, 10. Next in position 0, nothing follows. So we'll, at this point it's so clear if there is any doubt. Are you okay with this? So now the shoulder pain would have gone now, so you can raise the hand. Okay. Shall I now go to the next? Ready? Yes. Head is 1. How do you get temp? Increment from the earlier one now becomes 2. At that position I put 40. Now we have to traverse. Previous is grounded. Present takes the value of head. Okay? So what do? We compare the value in that node with the new value added, 10 less than 40, go to the next node. How do you go to the next node? Previous takes the value of present, and present takes link of present. So present is 1, link of present is 0, so this becomes 0. Exactly same as what we've done in point reversion. 1 and 0. Present value here is 20, is less than 40. I should go to the next one. Previous takes the value of present. Present takes the value of link of present, which is -1. That means we have come to the end of the list. Present becomes -1, we have come to the end of the list. That means this case is a case of adding at the end. But there is no difference between adding in the middle or adding at the end. So previous link will take the value of temp. Previous link will take the value of temp. Temp link will take the value of present, which is -1. Did I go fast? Are you okay with this? Did I go fast? Are you okay? So we have considered the case empty list, beginning, end. Middle is one more case we have to consider. We'll take the last one itself. We're not done anything, right? So we'll start slowly here. The list is like this. Head at position 1, 10. Next element 20. Next 25. Next 40. Nothing follows. Right? Now I have to add 30. To add 30, I will increment temp from the earlier value. So I add 30 here. Okay. Element is added. To find the position, I have to traverse. So what should be the value of previous? Grounded, -1. Present is 1. Next, I look at the value 10 at the node present, less than 30. So what should I do? Go to the next node. What should happen now? What should happen to previous? Should become present. And present should become 0. Then what do? I check this value, 20 with 30. 20 less than 30 is still true. Go to the next one. Previous becomes 0. Present becomes 3. Now I'm checking. Is it 25 less than 30? It is still true. Go to the next one. Previous becomes 3. Present becomes 2. Right? 40 is not less than 30. We got a position to insert. How do we insert? Link of previous should take temp. Previous link. We insert between the previous and the present nodes. The link of previous should take the value of temp. Previous is 3. Link of previous should take the value of temp. And link of temp should take the value of, temp is 4, I'm sorry. And link of temp should take the value of present, which is 2. So if I traverse 10, 20, 25, 30, 40, and nothing follows. Okay, now? Now, What if I want to delete a node from this? What should we delete? We'll delete 25 from this. Okay? Do you want to take a snap or anything? I have to clear it off. I don't have space. If any of you want to take a snap or anything, you're all welcome. Do you allow mobile phones in the classrooms? You allow? Oh, so nice. Okay. So once in 2011, we had a placement training. It was for all people in our college. So we had around 2,000 people for some 4 days. Just pin drop silence. And we said, you can use a mobile, send SMS to us, and we receive that SMS as a mail. So one of my friends was sitting with me. He is working in Intel now. So as soon as he got a mail, he would show me, then immediately I could answer. Even with 2,000 people, we had interactive session. Right? So, shall I? Okay. So now, you can come out and take if you want. You can come out here and take. Any of you can just come out and do, no issues. Okay, I'll take the last snap. I'll rewrite that. Okay. So help me delete 25. We're making it simple. We're not looking at the root node being deleted. So how do we delete? We discussed earlier, right? In linked list. How to delete 25? We'll have again 2 pointers, right? So we'll have previous and present. We are going to walk through what shall be the previous value. Previous value is always -1. Present should be same as the head. So what do we do? Compare 10 with 25. They don't match. What do we do? Go to the next. So previous becomes 1. Present becomes 0. Link of present, right? 0. Then what happens? We're comparing 20 with 25. They don't match. So previous becomes 0. Present becomes 3. Now they match. What do you think we should do? We should short circuit, right? Jump over. How do you jump over? Previous link should become present link. Previous arrow link should become present arrow link. That's why you jump over, right? So what do you think I should do here similarly? Previous link, present link is what? 3, 4. That should be copied to previous link. So this should become 4. Okay, now walk through this and see what happens. Will we ever reach 25? Just check. First here 10. Next is 20. Next is 30. Next is 40. That's it. We'll never go to 25 at all. 25 has been conceptually deleted from the array. No issue, right? That way I can delete. Can I add now 15 to this? Are you okay with this deletion? Can I add 15 to this list? Is the list full or does it have a slot? There's a place, right? So can I add 15 now? Where shall I add 15? Why not? There's a slot, right? Correct. No, the point is, this is conceptually empty. Huh? I can't do that, but I should know where to. We should get a value for temp, right? I can't make it temp for 5 now. If temp somehow can become 3, I can put it. There is a slot available, agreed? Do you know where it is? Where is it? How do we know? Because we just did that, we remember. And what if we keep on deleting number of times in a huge array? Where do you remember all those indices? When you walk through using the head, will I ever be able to make out which slot is free? No, right? If you go through indices directly also, you can't make out. How will you make out? Sorting won't help at all. If I walk through this, can I make out that this is free? There is no way we can make out. But in any case of a list, we use a list when we have deletions and insertions. If we have very few of them, we use an array. Why do you use a list at all? Extra space required, isn't it? So is there a way to support simple insertion here? Whenever slots are available, it should be able to insert. Can you do something like this?
When I free for a particular element, for example 25, the next index of the 25 element is 4, which is there. I will set it to null to identify whether that is not a part of it.
You want to make it null? If you make it null here, it's also null. Would that mean this also is empty? I like that. Here, friend says very interesting. Put some index to indicate it's free. Put -2, because we said, one of you asked me, right? We said 0 to some number is valid index. So to have null, we use -1. Maybe to indicate something is free, we use -2. That's interesting. Think of it. Let's say we have a huge array. Over a period, maybe there are lakhs of elements. If I want to insert now, what do you think I should do? Walk through all this and find one value of -2. What will be the complexity of that particular searching? Finding -2 in an array? Worst case, we do all elements, right? It will become linear, O of n, correct? That's fine, but it is not very helpful because it's not going to be simple. It's going to be costly in terms of searching, Orderian algorithm, linear algorithm.
So can we have another array where we can add whichever position is free?
I like that. So can we do something like this? Here we have one list, right? Can we have two lists? A list of filled elements, a list of free elements. That's what malloc does internally. Whenever you free, it puts it in a free block. The difference between the two is that in case of a list of free blocks, is there a difference between the blocks? They're same, all are free, so it doesn't make a difference, right? Okay, so what we'll try to do is this. We'll go through this process as quickly as possible, the same thing all over. Help me quickly. Each time we'll have two lists, a filled list and a free list, therefore two heads, right? So that's all it is. After that, next thing is simple. You got the idea, right? Why putting a -2 is not a good idea, even though it works. So we are now trying to keep a filled list and a free list together, right? Then we'll see whether we require two arrays. Okay. In the beginning, this is the filled list. This is the free list. So this is empty, right? -1. What should this be? Which element is free in the beginning? Is 0 free? 0 is free, right? So I can make it 0 here. Which is the next element free? Is 1 free? Is 2 free? 3 free? 4 free? And after that? No, -1. Just think of this before we proceed. Each time I must update the free list and the filled list. What I'm saying in the free list, 0th element is free. Then next element free is in position 1. Next element free is in position 2. Next element free is in position 3. Next element free is in position 4. Nothing is free after that. Okay? Remember how we got temp last time? Temp, we said, will go from 0 to 4. No, nothing of the kind now. Temp has to come from this list, from the free list. In case of filled list, the values decide the ordering. In case of a free list, all the elements are same, right? So I can pick up any of these for temp. Which one shall I pick up? From a list, if all of them are equivalent, should I pick up in the beginning or the end? All the elements are same. From which position shall I pick up, the beginning or the end? Choose beginning, easy. Correct, you don't have to traverse. So what we do is always in this particular free list, whenever I have to pick up from the beginning. When I want to add, also add in the beginning. Effectively, I look like a stack now, in a way. Right? One end only we operate. So we pick up from the beginning for temp. So which is the first element free for me? H2, right? That is 0. So I pick up the 0th position and put 20 here. So when I remove the first element of the list, what will happen? I removed the first element, right? What should happen? When I remove the element to which head points to, what should happen to head? Head arrow link. That's it. So head will change. H2 will now become head arrow link, which is 1. And we know how to insert in the field list. That again I won't go through. So I'll make this 0 and this is -1. That I'm going to do quickly. There's a question, please ask, but this I will take care. Have a look at this now. Field list, look at the field list. Which is the first element in the field list? 0. Nothing follows. Which is the first element in the free list? 1. Next is 2, next is 3, next is 4, nothing follows. So each time I get the free node from the free list. That is the value of temp. Not going to increment here. Put the element in the field list and adjust that indices. From the free list, remove the first node each time. Done? So what do you think I should do in the next case? I think next I had 10. So what should be the value of temp? What should be the value of temp? H2. H2. That's 1. And then change H2 to 2. And insert at the position 1 the value 10. That will change H1 to 1. And this becomes 0. This I'm writing directly. I'm not going through again. But verify whether things are okay. First element in the field list is in position 1. Next in position 0. And nothing follows. First in the free list is in position 2. Next in position 3. Next in position 4. Nothing follows. Right? Okay, we are inserting 40. How do we do? T becomes 2 and H2 becomes link of H2, which comes 3, and we insert 40 here. And this insertion will change this to 2, this to -1. I'm not going through the cycle again. We have discussed that at length. So what do we have now? Field list, This is 1, right? H1 should be 1. Okay. So the first element in position 1, next in position 0, next in position 2, nothing follows. Then first free element in position 3, next in position 4, nothing follows. Okay. So each time we get T from the free list. Okay? So what do we do now? Where I think we put 30 and 25, right? 25 and 30, okay. So T should become 3 and this becomes 4 and we insert 25 here. It will come between 20 and 40. So this will become 3 and this will become 2. So if we traverse first element in 10, next is 20, next is 25, next is 40, nothing follows. Free list, first element free is here and nothing follows. Right? How about the next case? So H1 is 1, H2 is 4. So what do you think? What should T become? 4. So here I put 30. And what should H2 become? -1, nothing follows. And while they insert, it will be between 25 and 40. So this should become 4 and this should become 2. So if I traverse first element here, next here, next here, next here, next here, nothing follows, nothing is free. If I now try to again insert, this will fail because I can't get a value for temp. Are you okay with this concept that by using two lists, I can track what is free and what is not free? On this, if I delete, how will I do it? Another, I think, 10 minutes max. I think I should be through. Okay. So how do we delete 25 from this? So we'll have previous -1, present same as H1, compare 10 with 25, they don't match. Previous takes the value of present, present takes the value of link of present is 0. Compare 20 with 25, they don't match. So this becomes 0, this becomes 3. So something is wrong?
So you have to start with comparing.
No, there's something wrong in this. 3, this is correct. Oh, I wrote wrongly here. Okay. Fine. So now they match. When they match, what should I do? I should do 2 things. I must remove that from the field list, add that to the field list. How to remove from the field list? Previous link should take the value of present link. Present link is 4, so this should become 4. Once I do this, let's check. First element here, 0, next here, 20, next 30, next 40. Now this particular node has to be added to the field list. And always I said we'll do in the beginning itself. Add in the beginning of the list, what will happen? The head should change. So I'll make head same as 3. And whatever is the head here, I'll copy to this. Think of inserting in the beginning. Head becomes temp. Before the temp arrow link becomes the head. Right? See if you can imagine. So now, if I look at element 3 is free, nothing follows it. Right? So I can directly go pick up this element the way I've been doing here and add one more element to this. I can remove any number of elements, add number of elements, as long as there are total number of elements, if within that range I can manage. That's what happens in memory management. When you do a malloc, you require a particular size. When you do free, it doesn't matter. It can go anywhere, yeah.
There is one element already there in free and you have performed delete.
No problem at all. When you do it again, let's say we delete 10. Then this head will now become 1. And link of this will take the value of 0. It'll insert that in the beginning.
So 2 pointers.
Two changes have to happen. Whatever is the value of head will go to the link field. Head will change to that particular thing.
In this case, we directly put -1 there.
Oh, that was because of the H2 itself. We copied H2 basically, right? Think of something like a stack operation. It's like a stack in a way, because we don't distinguish the nodes there. Okay. Now, are you comfortable now at least? How many of you want to try this in the afternoon today? I'll give you lots of things which you can't try in a short time. Any of you want to try this in the afternoon? It should be fun. Okay. Just now, one question, after that we'll stop. Can a particular slot be free as well as filled at the same time? Think of it. Can a slot be free as well as filled at the same time? Are they mutually exclusive? They have to be, right? There's no way something can be filled as well as free. Now the question is, do we require 2 arrays for this? Or can you merge the 2 arrays to a single array? This is a list of filled ones. This is a list of free. Any slot will be either free or filled, can't be both simultaneously. Why not put them in a single array? Why waste one more array for this? 2 heads definitely yes, because there are 2 lists. They're interwoven in a single array. So you don't require 2 arrays at all. Okay? So with this, I will stop the session. In the afternoon, we'll try hands-on. We'll continue with the linked list operation and see if we can try out something. I'll make it and give you. And if any of you are interested, this also you can try. I'll tell you how to go about doing it. Okay, so we end the lecture session for day 1. I'll be back on day 3 with you. For some reason, my friend wanted to take tomorrow, Dr. Viraj. Amazing teacher he is, very exciting. So out of 5 days, 4 days I knocked. I'm teaching you for 2 days. Then Dr. Venkatesh Choppella from IIIT Hyderabad also is very interesting. Dr. Viraj is just amazing. We have been together. I think I'll attend the class because I have free. I don't know whether I can go around in Goa this time of the year. Would any of you suggest you can go around? Where? In this hot sun? And compared to Bangalore, this is highly humid also. Highly humid. Bangalore also has become very hot. I don't know. I think I'll come and sit here. I'll attend Viraj's lecture. Okay. So any comments, feedback for me so that I can fine-tune my next day, algorithm day? Was it too light today? Or was it heavy?
Like if you can run through with us, then it would be good.
Run through what?
Run through like this equations this
Ah.
way, and then you understand.
Okay. You can interrupt me anytime. I don't have a totally fixed way of teaching, no matter which subject I teach, no matter whether I teach in college or in the industry. I keep it flexible. I take questions and based on that, diverge if necessary. So anything you want to tell me for Wednesday? We're discussing about algorithms, how to think, how to come with different solutions for a given problem. Nothing to say? Okay, so we'll break now and come back after lunch and hopefully get your MinGW installed if it's not Ubuntu. And I'll also share the files by the time.